So I will speak mainly on our contribution because we contribute in mainly two aspects concerning climate change. The first aspect is related to mitigation. Mitigation, I mean, how to achieve a certain level of greenhouse gas emission and how to allocate the burden of the abatement to different regions, different countries. This is the first aspect on mitigation. The second aspect in which we contribute is to try to understand the economic cost of climate change. This is what will be the cost of global warming on different economic sectors, but also what could be the adaptation in respect to this climate change issue. And we analyze different case studies or different impact concerning different sectors. Mainly we analyze the impact on health, on disease, but also human mortality and human disease. We also analyze the impact of climate change on energy consumption, because we can expect that if we have a global warming, we will have a decrease of heating needs and also increase of cooling needs. And we also analyze the impact of climate change on agricultural sectors, because of course, if we suppose that they have different precipitation, but for different temperatures, this will induce some change in agricultural sectors. The last topic that we have trying to understand or to analyze is related to sea level rise. And this is only what Santosh did concerning the impact of sea level rise.
Yes. For the complex issues like climate change, we try to integrate a different system of models that we use. We use climate models, plasma ins. We use TM world for energy energy analysis. We use LPGML for agriculture, and all these information we integrate in Gemini E3. That's the economic model we have. Using these models, we try to analyze different aspects of the economy. So I would like to go a bit more on the sea level rise. What we did in the sea level rise, we have a lot of uncertainties coming from the different models. We try to incorporate that. It's from the climate science, also from how the sea level rise will be in the future. And we try to do that economic impacts of that in a Gemini E3 economic model. We also look into how the coastal development will be in the future. So we try to integrate all these aspects and look the economic impacts of that. What we find is that it is not just the uncertainties of the sea level rise, but also there is quite a lot of uncertainties in the coastal development, like urban areas, how the urban areas will grow, or how the people in the coastal area might grow. So that could also have huge impact. So we need to also do the coastal management at the same time to protect the coastal areas. That's what we did.
On the economic side, when we try to analyze the climate change issue, climate change problems, what we first find is that we have to use bricks coming from different fields. I mean, we have to use information coming from climate science itself, of course, the impact of greenhouse gas concentration in temperature. We also have to take information or models coming from agricultural sectors, I mean vegetation model. So you have the main issue is to try to understand these different bricks, and also to try to with the different bricks to build a consistent, I will say, wall or building. And of course you have to communicate with people working in different fields, And it's a great issue to understand and to try to harmonize all these models, all these tools, all these fields.
Yeah, as I agree with Mark completely that we have to look into the holistic approach when you use to analyze the climate impacts of climate change. So what we achieve in this project is we were able to couple different system of models and then and try to give the results that's valuable for policymakers or for different academic and institutions. I think this project has achieved that goal.
Of course, as it is a research project, it's always, there's always steps. We have to work step by step. So there is always improvement to do in a research project. Well, I think that we achieve a very good result and very good coupling of model. For example, at the beginning of the project, we have to use models coming from different sides to use in the same platform. And so at the end of the project, we have all these tools. We have the platform that it is available, and we already did some scenario analysis or case studies analysis. But of course, now the platform is here, the models are here, and we can try to do more analysis with these tools.
Yeah, I completely agree with Mark. We still have to, we have looked into few sectors that energy, agriculture, and human health, but there are still more, impacts of climate change that we can look into, like into biodiversity or into water resources or, certain countries. In certain countries, there might be the effect of tourism. So we also need to integrate, different sectors that we need to do.
As a researcher, I don't have to be optimistic or pessimistic. It's not my job. I have to, as a citizen or a human person, I can be pessimistic or optimistic. But here we have to deal with different things, the different problem, and to solve it. Optimistic or pessimistic is out of science, I think. It's personal judgment. Of course, I have my own personal judgment, but it's not a researcher judgment. So don't say nothing on to be optimistic or pessimistic. What we try to do is to understand a huge problem, to try to do some solution, and at the end, what we have to do is to propose some solution, and politicians or people have to choose between this sample of solution that we can find. I don't know if you agree, Santosh.
Yeah, I agree. As a scientist, our job is to look at what could happen, what are the possible different scenarios in the future. So, we saw that in our results that how the future will look like. So, what are the possible adaptations or mitigation options that there could be, and we give these suggestions to policymakers, and then they can decide what to do. Yeah.